Hi, my name's BBrooks. I'm from URS Lighting. I'm a senior electrical engineer and lighting specialist. Today I'm going to talk to you about lighting impact assessments. I'm going to run through the process and methodology that we usually take with a lighting impact assessment, which I hope will help to address some of the questions yesterday of what is usually included in a lighting assessment. I'll also talk about some mitigation measures that we've used and some examples. Okay, an important part of the lighting impact assessment is the baseline survey. This helps us build up a picture of the baseline. We can look at where the sensitive areas are, topography of the land. We take photographs and do a daytime and a nighttime visit. We record light source, location, details, and take some lighting measurements of both illuminance and sometimes luminance depending on the situation. This helps to inform the environmental zone, which we sometimes need to make an assumption, and possibly zones may overlap within a site development area. This is an example from a baseline survey showing the points that we looked at and agreed vantage points that photographs were taken and measurements were taken, and also with further detail and a couple of example pictures there. It can also show how it's really good at informing us what's on the site already. In this instance, there was a lot of obtrusive lighting already on the site. There's very high masts with 3 or 4 floodlights on them, lighting an area that didn't need to be lit. It was storage containers that wasn't being used at night. And you can see the view from about 1/4 of a mile away, where it's very obtrusive and it's affecting the night sky. Okay, so the next stage is looking at proposing a suitable scheme. These are the things we need to consider. First of all, we need to understand what sensitive receptors are on the site and where these areas are, whether there are dark corridors, bat roofs that need to be protected that are existing, or perhaps new bat roofs that are proposed, and bat boxes. And I'm talking quite a bit about bats because that's the examples that I'll be talking about today, but also there's badger runs and other things that we have to consider. But we would look at this early stage so that we can consider it from the outset. We get the information from the ecologists, the draft reports, to make sure we understand the site and what the sensitive areas are. The next thing that we need to consider is the lighting requirements for the site. Determine the use and the task in the space, and also which areas need to be lit. There's often areas that don't need to be lit, as was discussed yesterday. Lots of pedestrian paths within residential areas don't need to be lit. Also, we need to consider whether these areas, making sure visual comfort, as we talked about yesterday, and fear of crime is covered so that people feel safe in the space. Our philosophy is often to make sure that the areas that are specifically for human use and activity are lit for that specifically, and then we keep the areas that are required to be dark as possible, dark corridors and the green infrastructure throughout the site. This is just an example of some of the light levels that we're talking about, ranging from 5 lux average illuminance on a pedestrian path up to 10 to 20 lux in medium traffic, heavy traffic areas and car parks, and also some of the levels that we come across in the natural environment. These levels from the code should always be used as maximum levels so that we're not overlighting areas. There was a lot of discussion yesterday about the light source, and I don't want to go into this in too much detail, but I do want to mention that we need to consider lots of factors to do with the source, which also affect maintenance, energy efficiency, and can impact on the control strategy that we can adopt. Also, luminaires. There is a lot of choice and options on luminaires from many different manufacturers, as we've already heard yesterday. Mounting heights and that kind of thing, and also luminous intensity and distribution varies. We've now got a lot of options available to us that can actually mitigate the need for shields and cowls, because some of the fittings already incorporate optics to reduce backlight and have narrow distributions, etc. Also, one other thing I'd like to highlight with this slide is we're often asked to provide low-level lighting in the form of bollards. But sometimes I think that this doesn't necessarily achieve the result that we would be after, because it can produce glare, and it doesn't produce cylindrical luminance to allow visual recognition for people using the space. facial recognition, sorry, for people using the face. And then, so from a human element, it's not really satisfying the requirements. We need to end up putting a lot more bollards in to light to the same levels as with a column installation. It's difficult to achieve uniformity. Also, there's a high component of upward light from these fittings, which is usually not within the guidance of the obtrusive light, which we saw yesterday. Also, they can be very energy inefficient. Another thing to consider is the control strategy. On most installations, considering exterior, timers and photo cells are usually always included. Obviously, movement detectors, dimming and part lighting strategies are other options. We also need to consider limiting obtrusive light from a human perspective onto residential areas and windows. Also, this affects sky glow, upward light ratio from the fittings, and building luminance. The next stage of the process for us is to put the information to do the scheme into a 3D model. This can be looking at the impacts from the external lighting, but also from internal lighting, which I don't think has been mentioned much yet at this conference. But internal lighting can provide quite a lot of light spill out onto dark corridors, and sometimes the houses are positioned close to the dark corridor, so it's quite an issue with large windows, etc. Considering options for mitigation, the first one that we think is most important is careful aiming and positioning of luminaires. Often I think the simplest strategy is the best. We can ensure that this is how it's going to be installed. Choosing suitable luminous intensity distributions, because we do have a lot of options available to us now as technologies have improved. Also, another simple strategy is to provide natural artificial screening, whether we use the topography of the land that is already there, or introduce banks and features, hedgerows, and even fencing and walls. Additional shields and baffles, towels, etc. have been mentioned. This is something that we try to use really as a last resort because of some of the things mentioned about post-installation, whether they're going to be fitted correctly. But as we go forward and there are tests on site post-installation, I think this will be more of an option as well. But also, I think technologies sometimes mean that they're not needed. If we're involved in an early stage, we can also impact on the site layout. Another option is to reduce the lighting levels below that of the guidance, and to do this we usually liaise with the client and they produce a risk assessment to allow these levels to be reduced. This is two examples of site layout, just to illustrate how this can have a big impact on the sensitive areas. These are both energy from waste centres. On the left-hand side, you have one where there was 24-hour working in only half of the site, and the site that was visitor access only was on the side of the sensitive areas. This meant that the lighting could be turned off throughout the night and would only be needed to use for a few hours on winter nights. But the other one is a 24-hour access site with a one-way system that meant that there would be traffic and lighting throughout the night, throughout the site. And also in this instance, translucent materials were used for the building itself, which introduced another element of impact to consider. When we consider mitigation internally, we can revise window locations, head height and size in order to reduce the spill. We can reconsider the site setting out, and we can also consider installing recessed luminaires, which can reduce the light spill. Blinds, particularly automatic blinds, are another option, and reducing or changing the window transmittance, but this can have an effect on the view out and also on the thermal properties of the building. This is an example from a case study in the southwest where there was greater horseshoe bats. The dark corridors are shown around the edge, but the most important ones are along the western edge and the northern of the site. This is an example of the model that was produced. We modelled both the internal lighting and the external lighting on the site. As you can see, the external lighting is very well contained within the site and protected by the buildings, so it's not spilling into these dark areas. But the internal lighting was an issue on this site because, in particular, the lovely green space to the west of the site they wanted to use as a view-out position, so they didn't want to screen it with hedges and trees. And also the topography of the land added an extra element of difficulty to the installation. So in order to mitigate this, you can see from the diagram on the right that the dark corridor is shown in pink, and the blue buildings all had recessed lighting. They also there was no lighting to the rear gardens from an exterior point of view. And then we had an issue with the very buildings at the very north of the site. These still needed to have the impact reduced further, so we had to liaise with the architect in order to reduce the window sizes and the head height on these. This shows how it was reduced. It's a little bit difficult to make out. But there were already also bats flying through the area in the north, so we reduced it as much as we possibly could, and then at this stage it was accepted, and monitoring is going to be done post-installation. This is an example of another residential development. Just to show really, on this one there's a pinch point in the site where we had to install a luminaire. It's a column-mounted installation in line with the local authority requirements. The area to the north is the sensitive area, and we looked at just various options, still wanting to keep to an S4 standard for subsidiary road lighting. But by placing the light fitting on the opposite side of the road as far away from the hedge as we could, we were able to make sure we used a narrow distribution fitting so that it would limit the light spill as much as possible. I think maybe the ecologists thought that it would be better to put the fitting closer to the hedge, facing the opposite way. But as you can see, this produces a lot of backspill. We could have used shields, but it was actually a better solution to go putting the fitting further from the sensitive area and using one with good control and cut-off. This is the final solution. Another thing that's also added in this instance is, because it was a viewing area, the hedgerows actually stopped either side, and so we introduced making the hedge continuous along that area. This is just a final example. I've talked about internal lighting, mitigation and external lighting, and also sometimes we look at vehicles and their movement throughout the site and how this has an impact on the sensitive areas. And in this instance, we use just simple solutions of building obstructions and walls to stop the headlights spill into the sensitive areas. Our perspective on the keys to success is raising awareness, as I think has been talked about already today, of the role and the importance of impact assessments, and having an early involvement. We're often asked to get involved at a very late stage in the project, and this can then be difficult to have a say on the site setting out and things like that may not be thought about. Also, close collaboration with the rest of the team, making sure that we understand what areas are sensitive, what options we have for mitigation, talking to the architect, the landscape designer, and also to make sure that we provide the information that's required so that all the design team members and planning can make an informed decision. As we've talked about, to do with vertical planes, horizontal planes, there's lots of options in our models that we can add detail, and if we can be talked to about this, we can incorporate this. Thank you.